A practical method of finding a solution, numerical solution with a guess and the corresponding error. VD on at 0.6 volt. IR we have to find. We here diode connected through resistance. Here positive, here negative supply. 10 k ohms connected resistance. So here 10 minus 0.6 volt divided by 10k, then this is 10 per volt. Okay, 10 minus this is 10 volt. Okay, so error how much? Here 0.9594 milliamps. IR error 0.94023 milliamps. Error 0.03%. VD on 0.7. IR 10 minus 0.7 divided by 10k. Here 0.93 milliamps. So error approximately 1%. Here that is resistance VR R greater than sigma. So this is infinity going on iteration. Here VR Rm greater than 0. This is the diode characteristics. This resistance characteristics. IR ID. Working model equivalent circuit of a diode. Diode in on state. R on. How much? R on VR. Dou ID divided by dou VD equal to 1 by R on equal to ID divided by VT. Here diode in off, R off time, dou ID divided by dou VD equal to dou of I naught into V e power VD by VT minus 1. Here I naught divided by VT at VD equal to 0. Here approximately I naught divided by VT at VD equal to 0. Piecewise linear model. Here VT divided by I naught equal to 26 millivolt divided by 10 power minus 13. I naught divided by VT at VD equal to 0. So equal to 26 into 10. Here 26 into 10 power minus 10 ohms. Okay. So VT divided by I naught equal to 26 by 10 power minus 13 approximately equal to I naught divided by VT at VD greater than 0 condition. Application of the working model of the diode. Application of the working model of diode. Use equivalent circuit. Find V out when V in changing with time. V in IR, ID across the diode, VD, V out. Here this is equivalent circuit. Here in this VI characteristics, VD, IR by VT, this portion. Here VD in second iteration, VD1, VD0, VR, V in here, VD in second iteration, V in first iteration, R equal to IR minus 1 inverse V divided by VT. Here equal circuit V in R on VR. Between this PD, V out, V in VR. So this is VD. input output transfer characteristics. These are input output transfer. In this application of the working model continue, finding V out when V in has AC signal using equivalent circuit and through circuit equations. Finding V out when V out to be find out when VIN has AC signal using equivalent circuit and through circuit equations. We have to find. So V in AC signal, small signal, this one V in this V in DC signal, DC supply for this diode function. Here this V in total VIN. This is for that signal, a small signal. This is for input to DC. Resistance R ON V gamma V out total. So V out equal to V in R on divided by R caps R plus R on plus V gamma. 1 minute. Here V out V out equal to V in R on divided by R plus R on plus V gamma R plus R divided R plus R on plus V in R plus R on is R on plus divided by R plus R on. This V in time. So V out equal to R on divided by R plus R on into VINT. Application of the working model, interpretation of different parts of V out obtained through equations. V out equal to V out plus R on divided by R plus R on into VIN. Interpretation of different parts of V out obtained through equations. Interpretation of parts of V out in out transfer characteristics. Here in this large signal V in V out V gamma V in, here this is small signal AC signal transfer circuit. So here matching V out AC signal matching. Notion of small signal equivalent circuit, in out characteristics, large signal and small signal. V in here AC signal, DC signal, that is DC supply, is VD diode ID V out. Okay, here V in equivalent circuit. This equivalent circuit, V AC signal, DC voltage, here resistance, here VD, V gamma, here this V out, RN. Here in this equivalent circuit, we have to remove this DC and diode. So small signal, large signal, small signal, in out characteristics. So here these are K. So here this V gamma to be removed and RN only. It is the V out. So here this is linear, this is non-linear. So this point is the very important. Small signal equivalent circuit rules to get it graphical interpretation. Small signal equivalent circuit continued. Advantages of small signal equivalent circuit. Linearization of non-linear circuit with respect to Q point. Simpler circuit, superposition theorem is valid here. Validity of the linear circuit and the signals. Validity of the here actual advantages: linearization, simple circuit, superposition theory is valid. Small signal equal circuit. Basic structure characteristics equations of BJT. Bipolar junction transistor for normal operation. Base emitter junction J1 is in forward bias. Base collector junction J2 is in reverse bias. Current through J1 when J2 is far away. NPN transistor, emitter, collector, base. Here connected VBE in emitter side negative, in common base positive. Here in PN side, this is NP side. Here in PN side negative connected to base, positive connected to N. So here junction 1, this is junction 2. In junction 1 J1 BE base emitter. In junction 2 A2 BC base collector. Here IB equal to IE equal to I naught plus P naught into E power VBE divided by VT minus 1. Current through J1 when J2 is in near vicinity. Current through and isolated NP junction in forward bias. Current through J1 when J2 is far away. Minority carrier concentration around J1 in forward bias condition. NP of X equal to NP of naught 0 minus NP out 0 dot into e power minus x by ln plus np naught. np of 0 equal to np of 0 e power vp divided by vt. np naught equal to ni square divided by na. Here vpe emitter connected, base J1 A1 N region P region IJ1. Here from here emitter electron flow, from here hole flow. This is IJ1 equal to IN1 IP1. This is VPE. IP current, base current direction, emitter current direction. Here this is PNO. Here PNY. This is from here. What's happening? This is from here. So Pn of y is total ny p x direction is y direction, j junction, this is npx npfo. Here pn of y, this is pno. Here npo, here minus npo. This one, not this one. This npo, this one. Current through an isolated NP junction in a forward bias. Minority carrier concentration around J1 in forward bias condition. NP of X equal to NP of 0 minus NP of 0. O out into e power minus x by ln plus npo np naught equal to npo e power vpe vt. npo equal to ni square divided by na. Electron diffusion current In minus q A1 D